are moving on to the frustum of a cone and pyramid. What do we mean by a frustum? Assuming you're having a cone and that big cone, a small cone is cut off from the the top, or you're having a pyramid and a small pyramid is cut off from the top. The resulting shape is known as a frustum. So this is a frustum. This is a frustum. So you realize a part of this is cut off. That part that is cut off is known as a pyramid. A part of this is cut off. The part that is cut off is a cone. So the resulting shape will give us a frustum. Now let us look at this example. Find the capacity in liters of a bucket 24 centimeter in diameter at the top, 16 centimeter in diameter at the bottom, and 20 centimeter deep. So you are looking for the capacity of this bucket. So if this is the bucket, at the top of the bucket is 24 centimeter, at the bottom of the bucket is 16 centimeter. You realize that this, if you are to complete the shape of this bucket, it will give you a cone. So this bucket is taken to be what? The frustum. So at the top it is 24 centimeter, at the bottom it is 16 centimeter. The height of the bucket is 20 centimeter. So you are told to calculate the capacity. That means you are told to look for the volume of this frustum. So if you are doing that, you try to complete the drawing. So the part that is cut off, join it together with it. So that means from the top here is 24 centimeter. This place is 16 centimeter. So that part of the, if you remove this cone here, it will give us this resulting cone. So that means by the time you complete this drawing, you have a big cone like this. Then the part that is cut off is now the small cone. The diameter of this one is 24 centimeter. The diameter of this small cone will now give you 16 centimeter. You are told that the height from this place to this place is 20 centimeter. But you don't know the height of the cone, the imaginary cone we are talking about. So when you are doing something like this, you are having what? You have a big cone, you have a small cone. So to get the volume of this frustum, that means you need to look for the volume of this big cone. You look for the volume of this small cone that is cut off. You now subtract the volume of this small cone that is cut off from the big cone to get the volume of the frustum. So now, but before you can do that, if you are looking for volume of a cone is 1/3 pi r square h. So you realize that for the big cone, you can look for the radius from here. You divide the diameter by 2. Then you don't know the height. The height of the big cone will be from here to this place. So that means it will be 20 plus this place that we don't know, that we are using x to represent. Then for the small cone, you can get the radius of the small cone from this one. Divide the diameter by 2, you get 8 centimeter. Then the height will be x. But before we go on, we must first of all get the value for x. So you realize that this can be seen to be a ratio. The height of the small cone over the height of the big cone, they should be of the same ratio with the radius of the small cone over the radius of the big cone. The same thing as saying the ratio of the diameter of the small cone over the diameter of the big cone. It also has the same ratio of the slant height of the small cone over the slant height of the big cone. Now in the diagram here, you are given that the height of the small cone is what? X. height of the B cone will be what? X plus 20. So x over x plus 20 should be equal to, now since what you are giving here is the diameter, so the diameter of the small cone, which is 16, over the diameter of the big cone, 24. So they should have, the ratio of their dimension will be equal since they are similar cones. So x plus 20 is equal to 16 over 24. So we are looking for x, cross multiply 24 times x is 24, is equal to 16 times x plus 20. So 24 times x will give us 24x is equal to 16 into bracket x plus 20. So open the bracket, 24x is equal to 16x, 16 times x is x, 16 times 20 is 320. This is plus 16x. When you bring it to come to this other side, you now turn to minus. So you now have 24x minus 16x is equal to 320. Now, if that's 320, you now have 24 minus 16x is 8x is equal to 320. To get x, divide both sides by what? 8. So that x will give us 320 divided by 8 to give us 40 centimeter. It means that the value for your small cone is what? The height of the small cone is what? 40 centimeter. So you realize that the parameters for the big cone, the radius of the big cone, the radius of the big cone will be what? 24 divided by 2, which is 12 centimeter. The height of the big cone will now be what? X plus 20. Our x is 40 plus 20, which is 60 centimeter. That of the small cone, the radius of the small cone will be what? 16 divided by 2, which is 8 centimeter. And the height of the small cone will now be what? 40 centimeter, which is what? X. So that means it will now be easier for you to now look for the volume of the big cone, volume of the small cone. So to look for the volume of the frustum, the volume of the frustum will be what? Volume of the big cone. The volume of the frustum will be volume of the big cone minus the volume of the small cone. So let's look for the volume of the big cone. So which is what? 1 over 3 pi big R squared h. So the radius of the big cone, so 1 over 3 times pi is 22 over 7. The radius of the big cone is what? 12 centimeter. I put it there. 12 times 12 is 12 square. Then times the height of the big cone is now what? 60 centimeter. You put it there. So when you 3 here and 3 here 4. So multiply the meaning, you have 3,360 over 7 centimeter cube. Then you come to the volume of the small cone. So the volume of the small cone is 1 over 3 pi r squared h. 1 over 3 times pi is 22 over 7. The radius of the small cone is now 8 centimeter. The height is 40 centimeter. So you put the radius there, which is what? 8 square, which is 8 times 8, then times the height is what? 40. So that means when you multiply the numerator, you have 56,320 over 21 centimeters cube. So now the volume of the bucket will now be the volume of the big cone, which is 3,360 over 7 minus the volume of the small cone, 56,320 over 21. So if you look for the LCM, treat this both of them like fractions. The LCM of 7 and 21 will give us 21. How many 7 and 21? 3. 3 times 63,360 will give us 190,080. Then minus 21 in 21 is 1. 1 times this will give us 56,320. So if we now subtract the numerator, so 190,080 minus 56,320. So you get 133,760 divided by 21. If we divide it by 21, you get 6,369.52381 centimeter cube, which is approximately 6,370 centimeter cube. Now, if we are now converting this one to liters, so since they said we should look for the value in liters, find the capacity in liters. So we said that to convert centimeter cube to liters, you are going to what? You are going to divide by 1000. When you divide by 1000, you get what? 6.37 liters. Now let's consider the second example. For the second example, a fruitstone of a pyramid is 3 centimeters square at the top and 6 centimeters square at the bottom and is 5 centimeters high. Calculate the volume of the fruitstone. Calculate the volume of the fruitstone. To calculate the volume of the fruitstone, so let's look at it. If this is the fruitstone, they say at the top it is 5 centimeters. It is 3 centimeters at the top. At the bottom it is what? 6 centimeters. So it is 6 centimeters at the bottom. The bottom is also a square. Then they said the height of the fruitstone is what? 5 centimeters. So you are told to calculate the volume of the fruitstone. You have to calculate the volume of this fruitstone. Now, to calculate the volume of the fruitstone, so it means that volume of the pyramid is generally is 1/3 base area times height. So 1/3 base area times height. Now, if we now look at it, you realize that for us to be able to get this particular volume properly, we will need to complete the drawing of this. So you realize that the height of the fruitstone here is from here to here is 5 centimeters, and we don't know this imaginary triangle that is here, that is cut off, is what is now drawn here. So we don't know the height of that imaginary pyramid that is cut off from the head of the fruitstone. We will use X to represent it, and you are told that this side is what? If this side is this side from diagram, this is 3 centimeters and this is 6 centimeters. So the length of the base of the small pyramid, the ratio of the length of the base of the small pyramid over the length of the base of the big pyramid. So this is the big pyramid, this is the base, this is the small pyramid, this is the base. So the ratio of those lengths should be equal to the height of the small pyramid. Height of the small pyramid over the height of the big pyramid. So the length of the base of the small pyramid is what? 3. So this one is 3 over 6 should be equal to the height of the small pyramid, which is what? We said that is x over height of the big pyramid for x plus 5. So when you cross multiply, you having 3 times x plus 5 should be equal to 6 times x is 6x. Open the bracket, you have 3 times x is 3x. 3 times 5 is what? 15 is equal to 6x. So you try to collect like terms. So 15 is now, you now bring the 3x to come and join this one, now turn to minus 3x. 15 should be because 6x minus 3x is what? 3x. So divide both sides by 3 to get x. X will be equal to what? 5 centimeters. Now, to now get the volume of the fruitstone, for volume of the fruitstone will be equal to what? Volume of the big pyramid minus the volume of the small pyramid. So, to get the volume of the big pyramid, you realize that the base area of the big pyramid is what? 6. Is a square, which is what? 6 times 6 will give us 36 centimeters square. The height of the big pyramid is what? X plus 5. So we've got the value for x to be 5 plus 5. 5 plus 5 is 10 centimeters. So to look for the volume of the big pyramid, that's 1/3 times the area of the base, which is what? 36 is the base area, times the height, which is 10. So 1/3 times 36 times 10 will give us 120 centimeters cube. Then we need to look for the volume of the small pyramid. Volume of the small pyramid is 1/3 times the base area of the small pyramid. You know the base of the small pyramid is 3 times 3, which is a square, which is 9 centimeters square. The height of the small pyramid is what? Is 5 centimeters. So when you substitute here, you now have base area 1/3 times the base is what? 9 times 5. So which will give us 1/3 times 9 times 5 will now give us 15 centimeters square. So the volume of the footstool will now be the volume of the big pyramid, which is 120 centimeters square, minus volume of the small pyramid, which is what? 15 centimeters square. 120 minus 15 will now give us 105 centimeters square. So for the work practice, you are going to do this. You have number 1, a bucket is 12 centimeters in diameter at the top and 8 centimeters in diameter at the bottom and 4 centimeters deep. Calculate its volume. Number 2, a right pyramid on a base 10 meters square is 15 meters high. A. Find the volume of the pyramid. B. If the top 6 meters of the pyramid are removed, what is the volume of the remaining footstool? Number 3. A footstool of a pyramid is 16 centimeters square at the bottom, 6 centimeters square at the top, and 12 centimeters high. Find the volume of the footstool. Number 4. The volume of a right circular cone is 5 liters. Calculate the volumes of the two parts into which the cone is divided by a plane parallel to the base, 1/3 of the way down from the vertex to the base. Give your answer in the nearest milliliter. Thank you.